So hello everybody, this is Mark Sage, the Executive Director of the area, and welcome to our latest Area Research Committee webinar. I'm super excited to introduce Eric in a minute, but it will be about the EPRI report that they've done on safety using AR technologies. Now, whilst I know many of you listening will be area members, I'm just going to take a couple of minutes just to talk about the area before I hand over to Eric. So the area, it's a global membership funded not-for-profit alliance. We are dedicated and focused on helping to accelerate the adoption of enterprise AR. And we do that by helping support the growth of a comprehensive ecosystem. Eric, next slide, please. We are currently 65 members strong. Our members fit into 3 different segments. We have customers or enterprises that are deploying or have deployed AR. So you can see the likes of ExxonMobil, Boeing, Merrick, and a whole bunch of different organizations. A bigger group of providers of AR technologies, both hardware and software. And then we have a third group, which we call kind of non-commercial or grouped as non-commercial organizations. Government agencies, research institutes, universities, and standards organizations. And we're continuing to grow and all work together to help develop and accelerate the adoption of enterprise AR. Next slide, please, Eric. Just again, to give you an idea of what we do, we have these 4 strategic pillars, we call them. The first one is about delivering that thought leadership. It's about delivering information that business decision makers need to help them invest in AR. So focusing very much on what problems can be solved using AR, so the use cases, examples of those problems being solved in real life, so the case studies, what technologies are needed, and we find most importantly, and we're doing a lot of work on at the moment, is the ROI, the return on investment. How much did the technology cost, but more importantly, how much am I going to make or save? And we deliver that through kind of multiple channels and networking opportunities, which takes us onto the networking side. It's really important to bring the ecosystem together. We are actually running a area event in Reston in the coming weeks, and I'll be sending out information to people on this call very soon. And we're really excited to bring the ecosystem together to talk about the benefits and challenges of AR. We also work on the educate side, which is about closing the skills gap and just making sure that we have a steady set of skilled workers coming into the enterprise AR industry. So again, working with universities and educational organizations to provide anything from guest lecturing to support them on evaluating and creating courses, to setting them challenges, to ICE placements, and anything we can do to encourage a steady set of skilled workers. And then one of the probably the biggest areas at the moment is about reducing barriers to adoption. And this is very much where Eric's presentation comes into that area. We have a safety committee, which we'll be talking about later, but we also have a security committee, human factors, requirements, anything we can do to help each other, to discuss, to learn, to create a set of deliverables that will overcome the barriers to adoption. There's a lot of talk about pilot purgatory. What we're doing together is overcoming those problems by working through and helping each other and really driving forward the ecosystem. Next slide, please, Eric. And we find that delivering these webinars is a real great way of sharing information, especially with some of the experts in the industry. So you can see we've done a whole bunch of webinars over certainly the 4 years I've been involved in, even before that. So, I thoroughly recommend that you go to the area portal, the area website, and have a look under resources. And there's a page there for webinars and videos. And you can see it's been a whole range of different information. They're all freely available for you to listen to and to watch. So please take that opportunity to have a look at this. And this webinar will be up in the next couple of days. Okay, so next page then. So I'm super excited to hand over to Eric Bauman from EPRI, who's going to take us through the work that he's managed and EPRI have done on a very important subject area. I'm not going to talk anymore because Eric is he's Martin, you're a great talk about real expert in this space. So, Eric, thank you for the work that you've done, and I'll hand over to you now to take us through your research.
All right. Thank you very much, Mark, and good morning, good afternoon, good evening to all of you. I'm Eric Bauman. I manage our program on occupational health and safety. For those of you that may not know who EPRI is a not-for-profit research organization founded in 1973. We do work in all aspects of the electric sector: transmission, distribution, end use, efficiency, renewables, health, environment, safety, advanced materials, basically anything that touches or shouldn't touch the electric system is something in our area. We have members, or 25% of our work is supported by international members, so we are not just North American. So I really want to thank Mark for hosting these results today. I want to acknowledge Dr. Richard Marklin of Marquette University and Ashley Tull of Marquette University, who are our researchers for this project. And so I'm going to share with you those results. I'll give you citations for the reports. We have 2 of the reports that came out of this project, and they are in public domain and downloadable by you. I'll give you all that information as we go along. In the EPRI space, this whole area of digital workers and safety has a number of interest or activities. So in the program that I manage, it's things like the personal sensors and monitors. It's how do we make sure we work on the right equipment at the right time, the potential for using AR, VR, mixed R for safety training. We look at field applications. And in this case, we're looking at the safety of using digital technologies. Elsewhere in EPRI, we're doing things like the technology demonstrations in our generation and power delivery area, communications of devices and those challenges, using AR, VR, XR for training. For example, we've got a routine on maintenance of a Terry turbine, and we have one of my colleagues is creating a virtual Hogan's Alley for situational awareness training. In our generation area, we have a digital workers interest group, and there's much more. But just to let you know that across our enterprise, AR, VR, XR is one of the areas that we are exploring and helping our industry look at those opportunities. So today I'm going to focus, of course, on the safety using the digital technologies. And if anybody has to leave early from the webcast, here are the key takeaways. So we did, this has been about 2.5-year project. We did a literature review of existing studies. We did a field study of power plant tasks, and then a field study of manhole and vault tasks. We started off, as you can see here, with the literature review of existing studies from roughly third quarter 2017 into early 2018. And what we saw was little to no evidence of a similar study. A few bits and pieces here and there, but it appeared that the project that we envisioned was going to be, if not a first of its kind, perhaps a first of its scope. We looked at, when we used the RealWear HMT-1 and Microsoft HoloLens Gen 1, and that's important, and I'm going to come to why that was important as part of the study. We then undertook the power plant task that basically took up a good amount of time in 2018, and later in that year we started the manhole vault task, and that was concluded last year. In the literature review, and here's the citation, if you go to www.epri.com and you enter either this title or the product number, you will be able to download the literature review. And as you can see here, we found a few things in the literature that were apropos to what we were working on. There was a lot in the literature at this time on possible uses of AR. So it was a lot on the technology itself and its capabilities, but much less on the implications of using that technology. But again, feel free to download if you have some further interest. And again, the only caveat I would make is this was published in March 2018. So this work was 2017, early 2018, and it captures the literature up until that point. So what we found, what we saw and what we suspected from the beginning are some gaps in how does AR affect perception of safety, situational awareness, what about eye strain, what about muscle loading and fatigue on the neck, upper shoulders. Also, I'd say worker adoption, were they comfortable with it, and the like. So those were the early research gaps that we suspected before the literature review and were affirmed by the literature review. So what we did was we measured eye strain, situational awareness, productivity, muscle forces, worker acceptance. We had 5 coal feeder inspection tasks in the power plant, and also some daily activities, a walkabout. Power plant operators are literally and figuratively in touch with their plant, and part of it is these inspections and walkabouts. For vault and manhole tasks, we did inspection, a splice preparation where you're putting cables together, and then actually taping of cables. This latter set of tasks were longer, and that's relevant to consideration of these study results. So that's what we studied. Those are the devices we used. And essentially the results were, we saw some decrease in blink rates in users of the HoloLens. We saw little differences on muscle forces or fatigue across actually all 3 situations, using the HMT-1, the HoloLens, and no AR. So there's little impact on muscle forces. Situational awareness remained good. The workers generally preferred voice commands. They didn't really like the air tap. To give a little bit of findings away early here, they liked the HMT-1 because they had more of a field of vision, natural, right? The screen device is small, and they could easily flip the device up when they were walking around, and they rather preferred that. You'll see some numbers here as we go along, but those are the highlights. And why this matters is there's some suggestions here for future designs. They like the voice command. They're lightweight, and I hear in general that there is probably a trend to lighter weight that would certainly be advantageous in terms of muscle forces. You need to, the workers, one comment they had was with HoloLens Gen 1 was it was a little difficult to see the screen in bright light when they would walk outside. So that's just something to keep in mind. Again, they like being able to flip up the little screen on the HMT-1, and they like to having more of a field of vision. So just a couple things for consideration of future design. Also for safety managers, again, since we saw lower blink rates, if someone is wearing or workers are wearing the devices for a longer period of time, just like people that are staring at computer screens need a break for eye fatigue, and they may need something like that may be advisable. Additional studies. We would advocate for further studies that the researchers do look at some longer tasks, and you'll see the length of the tasks that we did in this initial study. It'd be good to have some longer tasks studied. And of course, you all know better than I of all the new and emerging technologies. Those, of course, would want to be factored into future studies. And also, cognitive loading of workers. How much stimuli can they take in? And there's some more suggestions in the report as well. Here are the two studies. Again, there's the top is the citation of the literature review, and the second is the results that I'm reviewing today. So again, just go to EPRI.com, plug in the title or plug in the number, and you should be able to download it. If you have any issues, you can reach out to Ask EPRI at EPRI.com, and one of our customer assistance center folks in Dallas or Charlotte who are employees of EPRI can help you out.
Eric,
okay,
sorry,
methodology.
Eric, sorry,
yes.
Mark, just real quick, and I'm sorry, I should have mentioned at the start, and I know someone has already asked, but if there's anyone got any questions, we're going to try and answer the questions at the end. So please use the question capability on the GoToMeeting part, and if Eric and I can't answer them straight away, we will come back to you via email as well. So my apologies, Eric. I know you're on full steam ahead there and doing a great job, but I just wanted to mention that because I think you probably get some really interesting questions. Back over to you,
yes,
sir.
Okay, yes, excellent, no problem. Good, thank you. Okay, let me plow in the methodology. I've already mentioned this. These were the three test conditions. So in terms of experimental design, the dependent variables were the muscle forces, and this is what we studied. We did the eye strain, the blink rate with the right eye and pupil diameter, task duration, and the subjective assessments using the Likert scale. Power plant workers. These are just some pictures of our subjects. By the way, I can't name the utility and the facility, but one of our member companies provided gratis access to all of our subjects, for a day at a time, and opened their facilities to us. And without this kind of cooperation, this study would have been a lot more difficult and a lot more costly. But we really appreciate their efforts. So these are real workers doing their job. So here's the inspection tasks. They're looking at belt tracking, cold flow, conveyor belts, scraper bars. So this is simply looking, does this look right? They are looking at valves. So here's a calcium bromide meter, verify the chemical's not leaking, it's valved in. Looking at number 3, checking the oil level, verifying oil on dipstick, confirming there are no leaks. Looking at the conveyor belt motor and checking for some leaks. Looking for leaks at the coal feeder side access doors. Here's, I mentioned the walkabouts. They're walking up and down stairs, climbing and descending ladders. And they're checking for non-normal conditions inside the plant and outside of the plant. So, for example, looking for debris on the facilities. So those were the conditions, what we were testing for. And then these were some of the the results. So you can see here that these were rather short duration tasks of 5 to 20 some seconds. And again, what we found was no significant differences between AR and no AR. These times did not include clicking time. It was only of the task for performance. But as you can see on the charts, there are almost no differences, and they were not, the differences that were there were not statistically significant. For the EMG, the muscle force reading, again, no significant difference between AR and no AR. We were a tad bit surprised about that, but that's where the numbers take us, and that's what we found. Blink rate. The red line indicates 7 blinks per minute when viewing a computer screen. That came from the literature, and what you can see here of the dark gray were the HoloLens, the HMT-1, and no AR. So you can see here that there were some differences in with the HoloLens. We did similar. You'll see similar with the task for the manhole vault. For the subjective assessment, again using the Likert scale, you can see that the workers. This is the workers ranking this ease of use. They like the HMT-1 a little better than the HoloLens. Comfort, discomfort, they like the HMT-1 a bit better. And as you can see, they ranked the HoloLens a little bit uncomfortable. So in terms of preference, if they had to use a HoloLens or an HMT-1, they like the HMT-1 a little better, but their first preference was no AR. They didn't see that the AR added a lot of value to them to do their tasks for equipment inspections. So I want to highlight these were very short inspections and short tasks. So you'll see a little bit of some differences, and I would speculate that for longer, more involved tasks, these kind of numbers might change. But this is what we found. This is where the numbers take us. Here's some of the comments from the plant operators. It does give some consistency to training. They see it as a tool, maybe not so much for qualified equipment inspections. They love the hands-free, the voice. The last bullet there on the left, I thought is a really good one. Is basically no matter whether an operator is new or a veteran, having these kind of checklists equalize the competence, if you will. I think that's a really interesting insight. On the other side, they thought, well, maybe people use this as a crutch, and they don't sort of get a full grasp or understanding of the equipment. Again, we're just reporting what they said. The depth of data really makes AR device useful, and it may be useful for a brand new process or a piece of equipment. Pros and cons: could assist with training, good tool, lots of possibilities, infinite information would be possible about equipment that could reduce human error. Again, the HoloLens not as comfortable to wear. A little bit heavy with HoloLens. They didn't like the finger tap, and the reason, by the way, I should mention this. In the Gen 1 of HoloLens, we were having initial problems with the voice recognition of HoloLens in a noisy power plant environment. So that's why we had to go to the air tap with the HoloLens. So, but that's the reason why. I'm told that Gen 2 has increased capability with the HoloLens. So, but in any event, that's what we had to work with starting in late 17 and into 18, and that's what we're able to do our testing around. Also, some on HMT-1, they like the lightweight, more comfortable, voice options great, works with prescription glasses. They have the option of flipping up the screen. On the other hand, the size is pretty small. And someone said it was still too obtrusive. But in general, they rather like the HMT-1 because of the field of vision and the ability to flip it back and out of sight. So what we see here is HoloLens may decrease blink rate compared to HMT-1 or no augmented reality. Blink rate is a risk factor for eye strain and dry eye syndrome. No significant difference in muscle forces, and no significant difference in task duration. We weren't really able to measure quality of work because the inspection is, it's binary. It's either you do it or not. It's very short term, so that is one, I'd say, in a sense, a limitation because the tasks were short. No significant difference in their perception of safety between AR and no AR. They felt a little bit more cautious about their situational awareness wearing the devices, but again, in general, they felt that they knew what was going on around them. They didn't feel that somehow they were disconnected from place, especially with the HMT-1 because they could flip it up again. Again, they kind of like the HMT-1 a little better, but again, no big significant difference between the two. Let's go on to the Manhole vault. So one thing we learned about from study 1 was, we should have some longer tasks. And so in study 2, there's one inspection, but the other 2 tasks were longer tasks. So the inspection, normally they use a layout card, they check cables, it's about a minute. When they're doing a splice prep, they've got some, dare I say, real work to do. That is, they've got some physical manual labor to do. So they're looking in the device, they're looking at their checklist. So it's a bit longer. So the duration can be 10 to 30 minutes, and splicing doing the splice, the taping of splice, they have to crimp 2 conductors together. They then hand tape the splice, and that was about 5 minutes. So tasks are a little bit longer. Again, the inspection, pretty short, 45 to 52 seconds. Splice prep was they're about, well, you can see 522 to 555 seconds. Splice is a little bit shorter than that, but certainly longer than the inspection. We looked at the muscle forces, and again, there was a little bit, but really not too much. As you can see there, they're all pretty comparable. Blink rate, there's the red line from the literature. You can see the blink rate were a little bit lower than HMT-1 or the no AR. So here's the pupil diameter. Again, you can see the differences in the change of the pupil diameter. Here's the ease of use. It's interesting that the results have come a little bit closer here together. HMT-1 is there about 4.5 compared to 3, so that's a tiny shift down. And so I suspect, again, speculation, that maybe because they were using these devices for longer tasks. That would be would be my speculation. Here's again the chart of do I like one more than the other? HMT-1, if they're going to use one or the other, they like the HMT-1 a little bit more than HoloLens. But their first preference was no AR, but you'll notice that the no AR preference for the power plant inspection task was larger. It was almost half. In fact, I think it was a bit over half. So for the manhole task, they saw a little bit more utility in having the HoloLens or the HMT-1. I think that's pretty interesting. Comments. Easier to use the screen. So in this case, they like the HoloLens a little more. Easy to use, and they saw that there was some more utility to having the HoloLens, and they didn't see it was quite as friendly as the HMT-1. Well, it's not as user-friendly as the HMT-1, sorry. A little cumbersome and distracting, a little difficult to write on paper, a little heavier, and some tasks don't really need the info that it gives. HMT-1, they like the lightweight, a little bit easier to use. They like the voice command, etc. And again, they question a little bit of, we're not sure that for these tasks that that having checklists and so on is really that significant or important. Again, these are relatively shorter tasks, so I would expect that if people are having longer tasks, they're in a manufacturing setting, or they've got a long task to do, an equipment repair task, maybe breaking down a piece of equipment, having to put it back together. I suspect some of these comments would change. So the findings: a little decrease in blink rate, not a big difference in muscle forces, not a big difference in work performance between AR and no AR. No significant difference in perceived safety, nor with situational awareness. Again, they like the HMT-1 a little more than HoloLens, but really not big differences. So to try to round this out, that's the first thorough ergonomic study of AR in industrial setting, again, that we could find. No big change in muscle forces from wearing AR for short time periods. Maybe some elevation of risk in eye strain, and maybe a little bit of, we picked up a little bit there on situational awareness, but not that significant. And again, they liked the HMT-1 because they felt a little bit more connected to their and ease of seeing their surroundings. Some suggestions: doing some more AR testing when you're wearing a task for longer durations, like maybe 2 hours or more. Definitely want to pay attention to the differences of risk of eye strain. And for our setting, it might be good for us to start looking at some other groups of workers, like potentially overhead workers or folks working in substations. We originally wanted to do some work for substation work. Unfortunately, this was the first of its kind. It took us longer to come up with all the protocol. There were some break-in periods with some of our testing devices, and we only had access to one worker a week. So it stretched out our study period a bit. So we weren't able to do that third test out in a substation environment. So it would be good to have additional testing. So those are some initial suggestions. I guess what I'd like to do is to try to wrap up here was, again, this is what we measured using the RealWear and the Gen 1 of the Microsoft HoloLens, and the results. Why we do this, why we wanted to do this study to begin with. We want to keep our workers safe and productive. We want to make sure everybody goes home whole at the end of their shift. And we want to extend people's careers. And tools like this, ergonomics, other things, have these capabilities and potential for doing all of these things. And this is what matters to us. Why we wanted to make sure we put these studies in the public domain is, we wanted to give some guidance to our EPRI members on safe use of AR in our environment, but we also wanted to get this out to inform all of you in the enterprise space, because you're the ones that are working on new hardware. You're the ones coming up and working with our folks and obviously other industries on software for future design. So the more that you can do to make it lightweight, to make it more useful, etc., well, that works to the advantage of our users. And as we use it, we inform you all to make better design. So that's why we put it in the public domain. And that's kind of the end. I've already reviewed, I think, some of these findings of possible next steps. And again, I'm going to leave this on the screen here so you can write these numbers down. And in a minute, I'll flick over to my contact information. I'll leave this up for a minute. And I guess, Mark, I think we have some time for questions.
We do, yes, thank you. And just a reminder, if anybody's got any questions, to put them into the questions box. I'll start with a few comments. And again, I'm not going to name any askers or individuals, and that wouldn't be right. But a few comments about the HoloLens 2, which I know was not ever part of this study, but the ability to flip away the screen a bit like the HTM-1, and also kind of gesture control. It's a bit more intuitive and kind of the hand tracking and stuff like that. So we know that's now entered the market. Of course, when Eric initially did this research, or asked for this research to be done, that device wasn't available.
Good. Thank you for. I heard that anecdotally, so thank you for referencing that, Mark.
Yeah, perfect. I think that's some good kind of feedback. So let's just ask another question. I think this is quite an interesting one. Do you have any kind of recommendations on when you talk about eye straining, the breaks and things like that, the duration and frequency? Was there any feedback from any of the people, any of the users at the time? Is that something you've thought about within EPRI?
No. The short answer is no. We haven't developed any recommendations for break. What I would offer at this point is perhaps similar guidelines to what folks use in terms of computer screen use. What I've heard is take a break every hour or something, something like that. I don't know what the right number is
Okay.
for this setting. That would, if we wanted to do something more definitive on that, I mean, you'd want to do some literature review and possibly some other work, but we did not address that in this.
And that's absolutely fine, Eric. I think it's an interesting question. And just, we were talking
Yep.
before this call about we've just had the Area 7th research proposal, and, a couple of proposals were, building on top of this and coming up with some kind of longer term measures that we could look at. So, hopefully we can carry on this good work within the area as well. So let me just jump back to another question, and this is similar to the one I just asked, and understand potentially if you haven't got an answer, but is there any feedback from the workers on the kind of relatively narrow field of view from the HoloLens? Did anyone comment about it's difficult to see or it's quite small?
I don't, the HoloLens or the HMT-1?
This was a specific question on the HoloLens.
On the HoloLens, okay. So anecdotally, I don't recall hearing any particular comments about the HoloLens. There was the general comment about the small screen was a little bit challenging, right? But again, they in general, right? As you can see that in general, they like the smaller lens, but at the end that may have been that was the HMT-1, but they in general they like that a little bit more because of that ability to flip up. And so I don't have anything definitive on that. I can certainly check with Ashley, who was on site for obviously running each of the studies, and see if there was any specific comment about the HoloLens screen itself.
Yeah, absolutely. And we're still in contact with Ashley as well, so I'm happy to help out with that, Eric. I think it's good. And I think it's a similar question, but which I'm sure you probably haven't got the answer to, but the impact on eye strain, using the monocular device, having basically the screen as in the HTM1, just using one eye. I think that's an interesting question. And again, over a period of time, would that cause any issues? So I don't know if you've got any comments or thoughts on that.
I don't, but that's really an excellent point that our participant makes there. That would be yet another reason for a longer task period in the study.
Okay.
Right, because these were all right. The inspection tasks were boom, very quick, and even some of the the splicing tasks were maybe 10 minutes. Definitely, if we're looking at longer task periods, that would definitely be something you'd want to look at as one of the dependent variables. Yeah, that's a really good point.
Yeah, that's a great question. A couple of questions on the actual people using the devices, and I'll put the two questions together. How did you recruit for the study? Did the kind of user say, hey, I want to be part of it? Or did you pick particular types of users? And did you do any screening of the participants?
It turned out we had more volunteers than we could accommodate. So they were eager. The workers were eager to do this. So this was, essentially, these are the tasks we wanted to do, and we worked with the leadership at the power plant and for the manhole vault folks, and said we need 12 volunteers and boom, we got all the volunteers. So we had no problem with recruitment.
Which is great. And in terms of screening, basically.
Yeah, I mean, you'll see in the report there was a variance of ages. So it turns out we had a variance of age. We had a variance in we had a variety of how shall I say this dimensions of people, their sizes, and so I feel that it wasn't rigorously, we didn't do a highly stratified sample, selection, but I think we got a nice little cross section of the typical workers for the power plants and in the vault manhole, and some of those numbers are reported in the study.
Okay, that's great. And I think just following on from that, and I think this is another excellent question. Did you use the same participants for study 1 and then in study 2? So did the people kind of do both studies, or were they a different set of people?
So a different set of people. So the power plant workers were power plant operators, which is a very discrete job title, and the manhole work are again a very discrete set of skills. These are trade. They're both trade, right? These are both bargaining unit, highly skilled folks. So they could not do the same task.
Okay. And I think a question along those lines, was it a sample size of 12 users in the second study?
Let me think for a second. That's my recollection. Maybe it was 13. It was about the same.
Okay. All right. Perfect. I'm kind of wary of time here as well. Let me just ask this one. Did you do any sort of kind of risk assessment before performing the experiments?
I guess I would take that to mean, did we anticipate any hazards that could be created by the conduct of the project? If that's the question, this study protocol had to go through the institutional review board at Marquette University. So that kind of hazard and impact on the worker or the subject is part of review. So this went through the IRB at Marquette.
Okay, perfect. Thank you for that.
If that doesn't answer the question, maybe they could ask it again on your chat room, or I'm happy to chat with the individual on a one-on-one basis.
Yeah, absolutely. Okay. Let me just ask another one, which is a little bit more technical. Did you standardize the postures in which the EMG data was collected, or are these average stroke peaks collected throughout the tasks? The operator's neck and trunk postures will affect the muscle response. Wondering how it was done. It's a technical question.
Right. I don't recall from our protocol whether there was specifically looking at the posture of each worker and trying somehow to make that totally consistent. I don't recall that from any of our conversations, and I don't recall that from our protocol. My recollection is, and again, I can check this out, whether we let them do the task as they did them.
Right.
Right. This was real. So the emphasis here were real workers doing real tasks as they
Yeah.
would naturally do them. Okay.
Absolutely. Yep. Understand. Okay, that's great. So I'm gonna ask you one final question, I think, and if anybody has got any other questions, please feel free to type away, because Eric's also going to show his last slide in a minute.
Oh, right.
So we'll pick up the questions, and Eric and I will answer them. So, and I think I know the answer to this one, but it's an interesting question. So, was there any measuring of efficiency in completion of the task, comparing the three options? You know, no AR, HoloLens, HMT-1.
Right. Yeah. Ideally, we would have obtained more insight from the project. Unfortunately, as we've learned with the inspection tasks, they were such short duration. We didn't see significant differences in the time of doing the task, nor did we see much differences in the time to do the tasks with in the vault manhole. So I think I know that if you were going to do something more definitive around productivity improvements, you need to do longer tasks. Again, that's another reason we were recommending that for whoever may undertake additional projects in this regard, to make sure the tasks are longer in duration. And then we'll capture better information on productivity, as well as the the ergonomic and blink rate and so on effects.
Perfect. Yeah, I think, and it goes back to, when I often talk about the best use cases or the best tasks, they're the kind of infrequent, complex, and need contextual information. It's a real sweet spot for use of a AR kind of solution and an AR wearable.
Yes.
Okay.
And I've heard that anecdotally as well from our technologists that are doing some of these applications in power plants and in the transmission distribution arena. For example, this product well, actually, this is a VR product of this breakdown of this Terry turbine, and that the people using that really like it. So I would agree that, or my speculation is, if folks have longer tasks, they're more intricate breakdown or assembly, that there would be improvement in productivity, of quality, and probably worker satisfaction. So I think what I'm hearing anecdotally is suggestive in that direction.
Agreed. Okay, well, Eric, it's just leaves me to thank you very much for what was a really interesting piece of work. Thank you from the kind of wider ecosystem, because it was definitely needed, and certainly, I'm with the area members want to kind of build upon this, and it's the kind of information that we need to help break down those barriers to adoption and just inform the wider ecosystem. So thank you. Thank you very much for a really insightful webinar. Thanks everybody for listening. As I said, it will be up on the website with all of the links as well. And let's just everyone carry on the great work. And again, Eric, thank you very much indeed.
Thank you for this opportunity to share with your members. Thank you, Mark. Thank you, everyone, for listening.
Thank you, everyone. Thank you. Bye.